Okay, look at this. You are all engaged. I can't even get people's attention. Hello? Hello? Everybody, look, and they're still talking here. I bet that by now, you're all fired up. And I bet that by now many of you have forgotten that I'm not here to talk about thermal expansion. I mean, the answer to this question doesn't matter. You've already proven my point here. You know, I'm here to talk about pedagogy, not about thermal expansion. Now imagine I'd given my, look at them, they're still talking about it. It doesn't matter, it's okay. Imagine I'd given my little lecture about thermal expansion, and then instead of asking you a question, I'd said, let's now apply this to rectangular metal plates with circular holes in it. We take one of these plates, put it in the oven, turn the temperature up, and the material expands, and the diameter of the hole, I'm going to keep you in suspense a little bit longer here, but you know, you would have been sleeping through it. Can you tell me anything more boring than rectangular metal plates with circular holes in it? And let's face it, I mean, this is not exciting stuff, right? Isn't it amazing how you can reawaken the curiosity of the human mind? Right? I mean, if I just told you about it, you would have been bored to death. Now you're dying to know the answer. If I were to tell you, oops, it's time for coffee break, and I go outside, you would have come running after me, right? Okay, well, before I tell you the answer, let's analyze what happened. You know? I asked you a question, you thought about the question, and then I had you make a commitment. You committed yourself by pushing a button. Right? And I told you, if you don't know for sure, just make it a game. But you made a commitment. After making that commitment, I asked you to turn to a neighbor, and you had to externalize your answer. I chose because blah, 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 blah. And what happened was something really interesting, because the discussion was no longer focused on the answer. All of a sudden you moved from the answer or a fact to the reasoning that leads you to it. So it's no longer the outcome, it's the process that becomes important. But, and this is perhaps the most important point, in this whole process, you became emotionally invested in the learning process. As I said before, if I were to walk away right now, you would come running to me, after me, right, to ask me the answer, even though I'm not here to talk about thermal expansion. So this emotional investment, I think, is very important, and I've shown you in a certain sense how you can get that emotional investment with things that at face value are not interesting at all, simply by turning them into a question. So in order to finish this process, I have to vote you again. So please enter what you now believe to be the right answer. If you've not changed your mind, you enter the same answer again. If you have changed your mind, you enter what you currently believe to be the right answer. Now we should come up close to 36, okay? So I have some bad news for you. I thought I'd given you a pretty clear lecture. And you thought so too, because you didn't ask me many questions. But only about 30% of you, which is right on the cutoff for when this works, got the right answer. So, in a sense, you've helped me make a very important point. Because in a sense, you've been telling me, Eric, your lecturing sucks. And of course, it's not quite fair, but really, you should have done your reading the day before. But I've pulled here one question totally out of context, try to give you a little bit of context. So, but let's see what happens. So I'm gonna project the new distribution. Before that, I'm gonna reveal what the right answer is. The right answer is Oh, look at this attention. I love it. I love it. It's just amazing, really. The right answer is answer number, I need a drum roll here. Number 1. And let's see how many of you got that right. Oh, a miracle happened. Look at that. I'm going to show the initial distribution together with the final one. Let's see here, question 5. So the blue is the initial, 26 initial, and that went to 54. So in spite of the fact that there was, actually too few people, only a quarter, 1 in 4 had the right answer, we managed to double that. That's very impressive. I can see many of you think, why is that whole guy? I don't want you to lie in bed tonight at 2 a.m. thinking, and look at that talking there. So let me take 1 minute of my valuable time to tell you why it's answer number 1. I need to hide this. Okay. So imagine you have a jar of jam in the refrigerator. Glass jar, metal. It's one of these ball jars. They have a ring and a metal plate. Take it out of the refrigerator, can't open it. What do? You run the metal lid under hot water. The ring expands, the hole gets bigger. You says, well, that's a ring. You asked about a plate. Okay, imagine we have a metal plate, rectangular metal plate, no hole in it. Now we take a pen and we draw a circle on it. We take the plate with the drawn circle on it, put it in the oven, the plate expands. What happens to that circle? Everything gets bigger, so the circle gets bigger too. You said, that's unfair. There's no hole. If there was a hole, then the atoms would expand into the hole. I'll tell you what's wrong with that idea. Imagine the atoms at the edge of the hole. We could go outside. It's a beautiful day. We could form a circle. All hold hands, right? And now we all step inside. What just happens to the distance between us? Gets smaller. It can't, because remember, our neighbor is shaking more. The only way to make the distance bigger is to remove a few of us, but atoms don't disappear like that, or to make the hole larger. You won't forget this. Okay, back to peer instruction. So I was able to show in the very first year that I used this, that I could double the gain, and eventually I even tripled it. The hole? Can we talk about that in the break? Okay. So the data that I collected doubled the gain on this conceptual instrument, improved the students' exam performance, and over the year I've actually tripled it. And many people in other fields have shown similar gains and increased retention of the material and increased retention of measures in STEM disciplines. I want to end here by basically revisiting the lecture again. I don't want to bash the lecture completely. After all, I'm giving you a lecture here, right? I mean, we've made it partially interactive, but still it's mostly a lecture. I think a lecture is great for motivation. TED Talks, I've seen many great TED Talks. But as the primary vehicle for teaching, I think there is a flaw with lectures. Yes?
I have a quick question.
Yes.
Let's say I have the right answer, but I reached the right answer the wrong way.
Yeah.
So I'm trying to convince you for the right answer, but I totally explained it with wrong approach. Then how can you make sure that the students are really teaching each other in the right way?
Yeah. So first of all, that requires a right answer, right? And I'm sure there are many of you who are teaching disciplines where there are not necessarily right or wrong answers. You can do it perfectly in those disciplines as well, because after all, it's about the reasoning process, right? I mean, you could, for example, let's say, and I'll get back to your question in just a second. Let's say you're teaching art history, and you get to the Renaissance and Botticelli, and you're showing the birth of Venus. And discussing some details in the birth of Venus, and there's this little fawn there in the bottom left corner. Botticelli is long dead. We have no idea why he really painted that fawn, and art historians have different interpretations. One way would be for you just to discuss the painting and to say, this is the interpretation, or this is one interpretation, that's another. Why not make the students part of thinking like an art historian and giving their interpretation and thinking about it and talking to each other, trying to find ways to convince the other person that their interpretation is more valid than the other. There will not in the end be a right answer, but you will still engage in the process of thinking. Now, back to your question, which is an excellent question. I mean, there are two things that can happen. It can be even worse, right? It could be that you're a student, you're very convincing. I'm a student, I'm very convincing. I talk you into the wrong answer. You had the right answer, but I talk you into the wrong answer. Might have happened here that somebody got talked into the wrong answer. So when I then wrap up, one person is going to go, the person who convinced the other that, you know, of the wrong answer will go, oops, I did the wrong thing there. And the person who has been talked into the wrong answer, the next time I don't listen to this person. So it corrects itself very quickly. Now, what you said is very interesting. What happens when I convince somebody for the wrong reasons of the right answer? That's why it's always very important to wrap the question up with the correct reasoning, which could either come from the instructor, like I just did, or if I'd had a little bit more time, I would have asked some of you to articulate your thinking. And then you have some control over the process. Okay? Okay, so let's go back to a lecture. What is it exactly that happened? One is it's really hard to pay utmost attention during a lecture. And the data at MIT that I want to show you were collected by a group at the Media Lab, Ross Picar's group. She does effective computing, and she developed a sensor. I'm actually wearing one right now because I'm going to use it in my class. Here it is. It's a prototype. This sensor measures electrodermal activity. They want to use this for pain monitoring and so on. So it has an accelerometer which subtracts any looks at when you move your arm, so that you don't get motor signals convoluting the other signals of sort of cognitive and emotional involvement of the brain. And I read a paper in 2010 where they basically showed the electronics of this sensor. And it's great, right? Because in a sense, you can measure overall brain activity. You cannot measure the difference between alpha, beta, gamma, waves in the brain, just like an EEG can. But you have some idea of overall brain activity. And if I would have to actually really measure brain activity here while I'm giving a talk, I would be walking around with electrodes on my head, and I'd look pretty strange. Right? But this, you hadn't probably even noticed that I was wearing something. So it's rather unobtrusive, and then later you can download the data. So they gave it to an MIT student for a week, and one of the graphs in this paper, which is not at all about education, is the data from an MIT student for 1 week. Here's the graph. So there's day 1, day 2, day 3, day 4, starting at 4 o'clock when the student started wearing it, till 3 o'clock the next day. They also asked the students to keep track of the activity that the student was involved in. I want to draw your attention to the parts of the trace labeled class. The trace goes flat. By the way, I wore it a few days ago during meetings just to see what would happen. Most meetings it goes pretty flat, especially big group meetings. Small group meetings, it's more animated. Compare that to sleep, which is this highlighted region. Now, sleep is very important cognitively, as we know. Brain is very active during sleep. So in other words, your students are less asleep in their beds than when they are in their classes. Now, don't look at the screen for a moment. Look at me here, because the answer to my next question is on the screen. There's one activity. So suppress the urge to look at the screen. There's one activity that matches class. What would that be? TV, exactly. There it goes. It's the only other part of the trace that's really flat. And that we've known for a long time. You put people in front of a TV, they go into a meditative state. And it's for the same reason. There might be emotions, but there's continuous, flow of information. There's no time to think. Why would a lecture, either live or online, be any different? Look at all the other activities, from homework, even chores. Chores probably because you're socially engaged, right? I mean, you're probably washing dishes and talking to somebody. There's more engagement there than in a lecture. The other thing is you come out thinking you know it. I've gone to many colloquia, and then an hour later I'm in the hallway, and there's a colleague who has not gone to the colloquium and says, did you go to this colloquium by this professor at the University of Chicago? Yeah, I went. How was it? Oh, I want to make my colleague feel bad. It was just absolutely brilliant. Really, well, what did this person talk about? You know, and then you realize, yeah, it all sounded brilliant, but, you know, reproducing it is a different thing. At the University of Iowa, they did a fantastic study, and for that I have to briefly talk about calico cats. Calico cats are cats that have 3 or more fur collars, and it's the X chromosome that encodes the fur collar. So 96% or so of calico cats are female. And so what they did is they asked a biologist to record 2 video segments on the genetics of calico cats, exactly the same content. Same lecture, same content. In one of the 2 videos, she delivered a eloquent lecture. She did never refer to her notes. She stood upright and looked straight at the camera. We'll call that the fluent video. Then they re-recorded exactly the same content, but she was basically reading her notes haltingly. She was slumped over her notes, and she looked away. She was never looking at the camera. They took a large bio class, split it in 2. Half the students saw the fluent video, the other half saw the disfluent video. Then immediately after seeing the video, they asked the students to predict how well they would do on a test. The students who had seen the fluent video predicted they would do twice as well as those who did the disfluent video. Then they distracted the students for 10 minutes with irrelevant tasks, and then they immediately tested them. And you know what? They did exactly the same. Right? If they would have asked the students to evaluate the teacher, they would have gotten very different evaluations. But so, you know, you think you know it, but you think you know it because you've not really been confronted with any misconceptions. You've not really had time to think about it. You are unaware that there are any conceptual difficulties. So you walk out of this class or this lecture with a completely false sense of security. And it's not only the students, it's the instructor too, thinking, God, I gave a clear lecture. Everybody understood it. But in the end, it's just an illusion. It's a house of cards, right? So education is not just about transferring information. I think it's really, and it's not about getting students to do what we do. Active participation is really a must. The other thing, and we need a break here, I want to emphasize it again, it's not the technology. We could have done exactly the same thing with hands on the chest, 1, 2, 3, 4, 5, or flashcards. It's the pedagogy that matters, not the technology. There are so many instructors who use clickers, and they simply lecture, and then they stop, and they say, which of the following is not a living being? A giraffe, a rock, a flower. The students click 2, the instructor says, good, and lectures on. No engagement, no thinking. It might be waking them up temporarily, but there's no processing of information. So thank you for this. Let's have a quick break, and then we reconvene to talk about assessment. Most students cannot do that. But that's okay, because I tell them you'll be evaluated on the effort you put in. What you have to do is you have to convince me that you've done the reading. Well, the only way you can convince somebody you've done the reading is actually read, right? And actually it's very easy to judge. You just scan the answers and you have a pretty good sense of whether they've actually done any reading or not. But those are not the important questions. The really important question is the last one, which is always the same question. Please tell me what you found difficult or confusing, or please tell me what questions you have about the material. If nothing was difficult or confusing, tell me what you found most interesting. The last part is there so that they can't get away by saying, I have no questions. Right? That's unacceptable. Then they have to explain what. But they get a chance to actually say, on page such and such, I don't understand why, blah, 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 blah. In class, the first slide that I show shows the areas where there were most of the questions. And then I say, let's turn to this first area. Let's say it's torque or whatever. I'm just picking something from my own discipline. And then on the screen, I put 3 quotes relating to that subject. A question which says, I don't understand why when this wheel turns, blah, 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 and so on. They see it verbatim, without a name, of course, but they see it. So if you've actually asked that question, you'll go, wow, that's my question, right? And if you had a similar question, you would think, well, I was wondering about that too. I didn't write it down, but I was wondering about it too. It tells the students you have looked at the questions, at the feedback from the students. And then rather than answering the questions, I turn those questions into questions that I ask in class, into clicker questions. So the questions that I ask in class are not based on what I can come up with. No, they're based on the questions that the students actually have. Now the in-class component is actually tightly coupled to the reading, and students very quickly discover that if they take the trouble of reading and communicating to you as the instructor what it is that they found difficult, that very quickly becomes an incentive. In the beginning, they do it just because they get credit for it. And you can see that by the way they articulate their questions. On the first, few weeks, they'll write, I'm confused about blah, 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 blah. But once they discover that there's that feedback loop, they'll say, it would be good if tomorrow in class we could, and then they want you to answer that question. So they've discovered that, they can feed you a question, and then in class that question will be discussed. Yes?
How long do you give yourself to respond to that feedback and then plan out how you're going to address it?
Okay, I do not respond to the feedback outside of class. I read it.
In terms of figuring out yourself how
Oh yeah, that's my only preparation, right? That's it. Instead of preparing a lecture, I now process the question. If I have a class of 250 students, I cannot read all 250. I read 40. But let me tell you, after reading 40, you have a pretty good sense. And the software that I use cycles me through the students, so that I don't always read the same 40 students. So, basically, it takes me the same amount of time as it would take me to prepare myself for a regular lecture. And if you've taught the course before, you find that the next year the same questions come up. So, you can go even faster the next year. More recently, I've used a slightly, and I learned this from Sanjoy Mahajan, who teaches here at Olin. I've been using a software, a social document annotation software called NB. I think it stands for Nota Bene, developed at MIT. The URL is nb.mit.edu. So what I do is I upload the textbook in PDF form or the notes to this social document annotation system. And the students read it on their electronic devices, computer, whatever they have, and they can annotate it. If there's something they don't understand, they can highlight it, and they type the question in context. Right, so they don't have to say on page such and such, I didn't understand. No, they highlight it and they type in their question. Other students reading it see the highlight. It's a very faint highlight. So they can click on that highlight and then the question pops up. If they know the answer, they can answer that other student's question. Or they can modify the question, or they can, So the text outside the class becomes a living document. I press on a button and I can see where the hotspots are. Literally, I see hotspots. Oh, lots of, annotations there. Let's dig into it. So now my task is actually even simpler than that, because the only thing I have to do is see where the questions cluster and then see if there are unresolved questions that the students haven't been able to, among themselves, be able to address. And I do that in class. I find that particularly useful for the type of classes that I teach now. So that's one thing I was going to talk. Yes? Yes.
I teach physical chemistry, which is very similar to physics. And I've been told by my students for 2 decades that if I were to give them my notes before class and expect them to read my notes, they would not be able to understand the material. They need to hear it first from me before they can go and read my notes and understand. I've asked this question of my students every year. It's always the same answer.
Well, I have a very strong reaction to that, but I want to, is there somebody, did everybody hear this? In other words, the students say, I need to hear it. What is there anybody else who wants to react to that before I? Yes.
Less energy on their parts, in some sense, less commitment on their parts. If they hear it first, then they're just going for pattern matching instead of actually doing the thinking.
maybe not. Maybe this stuff that I don't know are hard stuff. Okay, it's hard stuff. So, by looking at these notes, I can
But wouldn't the right solution then simply be, I forgot what your name is, Chris, wouldn't be the right thing for Chris to record the lectures then? And then instead of the notice, just have them look at the video. Have them look at the video. But I mean, let's talk briefly about the validity of that statement. Why is it the students are making that remark? After all, let's face it, right? When after 4 years, we give our students their diplomas, right? They study for 4 years and they graduate, we give them their diplomas. Does learning stop there? No. That's when it really starts. In fact, you know, we don't know what type of jobs they're going to take. In fact, some of the jobs that they're going to have might not exist today because, you know, as we know, things change. I mean, think about the internet, right? When we were in class, if you would have talked about things like internet, web design, SQL programming, it would have had no meaning. We would have not known what you were talking about, right? So still, we know that. We've learned that after graduation. So I think the skill of learning by reading on your own, is perhaps the most important skill that we can teach our students. I think the reason that our students ask that is because they've gone through 12 years or more of education where they've basically been fooled into believing you learn by listening. And they have that misconception. They think they learn by listening, not being aware of how they really learn, and secondly, not being aware that later in real life and in the real world, you know, we're not going to be there to hold their hands and read the book for them. Yes?
But what if you're wrong, right? What if it turns out that, you know, you've been sort of far on the lecture side, but there's a wonderful lecturer who just has the right model class and told the teachers the students with them, right? So it's something that they really could get from it, but they wouldn't get from the model. 20 years from now, the pendulum swings back the other way, we've lost all Chris's.
Oh, no. No, I
It's like there's a broad spectrum of ways you can teach.
yeah, absolutely.
Way to sort of move in another direction. It's
I-
not an endpoint.
I couldn't agree more with you. And I would say for all these brilliant lecturers, I think what we should do is we should film them. And we should fire all the bad lecturers and replace, which is probably 99% of us, and then replace the 99% of us that are not that great lecturers and replace them with the video of the good lecturers.
I mean, I'm worried about this intermediation of physical devices between the students and the person who's trying to interact.
Well,
You're not getting the drawing out that you're looking for.
well, I'm not saying we should empty these buildings, but I think we can replace. No, it's definitely not an A/B thing, and we can make better use of our time, and in particular better use of the students' time that way. My goal is to make sure that there's more personal interaction, because I would claim in a standard lecture there's very little personal interaction. You're standing in front of a crowd, they're looking at you. You have no idea what's going on in their brains. If you go, as I said, I make a habit of observing other classes, and I typically sit in the back because that allows me to see, you know, everything, including the students. You should do that. Go to large lecture classes, stop in the back, sit down, observe the students. The picture is very different than it is in the front. No, at Olin you don't. Right, absolutely.
I'm wondering if you were to have, I'm sorry, if you were to have small classes as part of the model, right, would lecturing come back again as a valuable way to interact with the class?
Well, I think some lecturing will definitely be valuable. But again, let's think again about this little exercise we did at the beginning. You learn by doing. You don't learn by listening. Yeah.
In the late 50s, there was a project by Annenberg that invested hundreds of millions of dollars in, quote, the best lecturers around, and they televised chemistry and other things, and that project sort of disappeared.
Absolutely.
And I'm wondering, because based on what you're saying, it could never have succeeded in terms of the master lecture and so on. There must have been studies about why it was failing and what was happening, and sort of there's very little residual memory of that project.
Well, I think that was the argument I was trying to make before we paused. But I think in general, video, and I think people are not realizing that is first of all a very expensive investment, which has two huge problems. One is the shelf life is very short. If you were to look at those lectures now, they look dated. Video looks very dated very quickly. In 2001, or 3, I forgot what it was, I made an interactive DVD. 10 years later, it looks old. The screens and, the computer screens you see in the background look like, really old, and the clothing changes. So the shelf life of video is very, very short. And there's another problem. A book from 10 years ago doesn't look old. And you can come out with a new edition. You can take the file for the book and you can change a few sentences here and there. You cannot do that with video. You have to start from scratch again. You cannot say, oh, I don't exactly like what that says there 3 years later, and change it. Because even if you find the same person, the person looks older, the clothing style changed, and so on. So there's just no way you can edit video the way you can edit a book. So I think there's a problem with making huge investments in video recordings of lectures, because they'll, A, get dated very quickly. They cannot be easily updated the way books can get updated. And the reason they fail is because people don't learn by listening, they learn by doing. Now, why is it so entrenched? And maybe I should briefly transition to this before we break up for lunch. I won't get to the more interesting part of my talk, I think, but it's been recorded, and I'll circulate the YouTube video. I have to start with a little anecdote here, because I think this is so important. I really realized only a couple of years ago that I'd put all this effort into changing the format of my teaching, but I never got all students on board. There were always some students who kept complaining, I want lectures, that's how I learn. Until I realized that, in a sense, the silent killer of what was happening in my class was really the assessment. About 1.5 years ago, I was boarding a flight in Newark to go to Buenos Aires. I was going to give a talk at the University of Buenos Aires. And I sat down in my seat, and next to me sat a young woman who had just obtained her degree from the University of Chicago. And we started talking, and she was working for a cloud-based education company. And I just started learning Catalytics, which is a cloud-based education company, so I thought I better find out what she's doing. It turns out her company was making flashcards for the iPhone, right? These cards that have questions on one, but then it was basically on the iPhone. I had trouble not rolling my eyes because, I don't believe in memorization, so I managed not to roll my eyes. But it turns out that just a week before that, I had attended a talk at a symposium at Harvard by a psychologist from Washington University by the name of Ruddy Roedinger. He studies memory, and in particular he studies memory from studying with flashcard. He wrote a paper in 2010 that showed that if a student studies with flashcard, and then you test 2 days later, a week later, and so on, you find that after 1 week, only 35% is retained. Okay? Of course, if you keep reinforcing it in between, it's longer. But if you study with flashcard and then you wait a week, only 35% of the information is retained. After 2 weeks, you can't even measure it anymore. After 1 or 2 days, it's still high. But I thought, she should. He also suggests some ways of actually retaining things longer. So I thought she should know about this, right? So I had downloaded that science paper on my iPad. So I bent over to my briefcase and got out the iPad, pulled the paper up, and I gave her my iPad. And she looked at the abstract for no longer than 10 seconds. And then she handed me my iPad back. And she looked me right in the eyes. And she said, "But we only guarantee that they will pass the test." And I went, wow, I never thought about it that way. And you know, it brought back all kinds of memory. My daughter, my oldest daughter, was a student at Harvard. She was a pre-med, bio major. And on Friday, she would come back home. I live west in Concord. And then on Monday morning, we'd drive together to campus. I'd be driving in the driver's seat, and she'd be sitting in the passenger seat next to me. I'd look over. Flashcards. Natalie, what are you doing with flashcards? She said, well, I have to I have to know all these amino acids. I said, well, you know, I have an app for that. Seriously, I do some of my work is in biophysics, and I need to know the amino acids from that I'm in, and I have a great app for amino acids. She says, yeah, but you know, we cannot use our iPhones during the exam. And that's, you know, my daughter and I often talk about education, and that made me realize that even with the best of intentions, if the testing environment forces students to memorize the information, then, you know, they're never going to be able to learn. And in fact, many of our students study not to learn, they study to pass the test. Anyway, I'm going to skip through some slides here. This was the message just now, but what I want to focus on, just before break, what I want to focus on now is that at many assessments, it's the inverse that happens. Right? The students regurgitating information back, right? The inverse of that process, which is why students want to get the information in the first place. And, you know, instead of focusing on developing 21st century skills, examinations really focus on sorting and ranking people. So I briefly, we won't have time because we need to go for lunch pretty soon. I want to briefly talk about the purposes, and then I think we might have a little bit of time to talk about one or two problems with assessment. I wish I had time to talk about some potential improvements. I won't, but as I said, this talk is on YouTube, so, you know, why am I even lecturing here to you? We should be talking about it. Yes?
A quick question that I'm trying to ask you. Did you observe any difference in your own evaluations by the students after switching?
Good question. Very little, actually. And in fact, there's an interesting study that was done by the psychology department at Harvard where they took snippets of video and had students evaluate instructors with the sound off by just looking at the person, first 5 minutes and then 2 minutes and so on, but just looking at the person and the gesticulation. Students who had not taken the class were evaluating these professors, and then they compared it to the actual assessment. Great correlation between the two, but the interesting part is that they started to shorten the segments. The correlation persists down to something like 2 seconds. In other words, you know, students, you know, they evaluate a person based on appearances, hidden prejudices come out, and so on, and this evaluation really is not a meaningful evaluation. It's not a meaningful evaluation. And, you know, also the timing, right? We ask students to evaluate a course before they have any time to reflect on the course. There's not been any time to think. There's not been any time to evaluate how meaningful what happened in the course was in the context of other courses, in the context of a later career. Why are we using, in fact, it's a flaw in the assessment of the courses. Why do we like to use such a meaningless metric? I think the only reason we like that is because it's easy to get. But I think it would be more important to get a more meaningful, because we take a lot of important decisions based on this quote-unquote meaningless metric. Thank you for asking that question. So let's do this. I want you to form little groups and make a list of the purpose of assessment. Why are we assessing students? What is the goal of assessing students? So try to come up with as long a list as you can. Okay? I want a minimum of 5 things on your list. So form a small group. Okay, well, I see that many of you, I want to try to get everybody's attention here again, have already more than 5. Good for you. So let's hear a few of the reasons, and I'm sure many of them will overlap. So give me a reason for assessment. Monitor progress. So for the instructor to monitor the progress of the students. More. Motivate the students.
Give them a deadline to synthesize information and summarize.
So maybe give them a deadline for synthesizing the information. Yes. Certify their competency, so accountability, basically. Which I would put under the category feedback to the students. Okay? For ranking the students. Do we really have to do that? Do we really have to do that? Why do we have to rank the students? For grad schools. Now let me ask you, I teach in a grad school and I see lots of records of incoming students. And I can tell you, not much correlation with how they actually do in grad school. How good are we at ranking people? I mean, ask yourself, how many people do we know who have straight A records but turn out not to be that great, and how many people do we know who flunk out of college and do spectacularly well? I mean, in fact, a lot of people do spectacularly well flunked out of college because they had something better to do. Bill Gates, Steve Jobs, you name it. I mean, there's a long, long list of artists, technology people, you name it, who have been very influential, who have no college degree to speak of. So I think there's an argument to be made that there's very little correlation, that ranking is a myth. I won't get to that part of my talk, unfortunately, but yeah.
So there is a difference between teaching and assessing people to get into a skill and how to be creative, how to think.
Very good.
For the skill part, it's a kind of easier to do these kind of things because you have some straight correlation between what you taught them and how well they learn it. For the thinking, it's really mind-boggling because we do not even know how we are creative. We can recognize creativity most of the time, but we do not know. So at that time, the assessment is kind of, personally, I find completely incompetent, even though
Thank you. Thank you. We'll get to that. We'll get to that. In fact, maybe in the interest of time, I should put up my list, which I'm sure will capture most of the things you've written down. One is to rate the students, which is what you said, ranking them. I mean, who is number 1, who is number 2, and so on. To rate the professor and the course, and sort of in an absolute way, and in terms of, you know, for the department. To motivate students to keep up with the work. To provide feedback on the learning to the students. To provide feedback to the instructor. Oh, gee, they don't understand this, right? Except that in that case, the feedback better come early, because if it comes at the end of the class, you can't do anything about it anymore. To provide, and then we heard that too, instructional accountability, and to improve the teaching and learning, to get feedback on how we might improve our approach. And of course, then there's another really important reason, so that we can go to conferences and do other things. I'm just joking there. But you know, if you look at this list, although I must admit that I have occasionally scheduled an exam right during an important meeting. But if you look at the verbs there, you see right away already a conflict, right? If you ask, by the way, students what the reasons for assessment is, they come up with sort of slightly different ones. I mean, they see it more as a punishment than anything else. I don't think that stress or punishment are conducive to learning. So we already see that just by analyzing the verbs on this list, that assessment poses a conflict. Okay, so let's now go to some of the problems. One is, I think that, and you sort of touched on that, is that many of the assessments are what I would call not an authentic assessment of the type of skills we want our students to develop. And I'm not just talking about sort of retrieval of factual information. I would say even tests that claim to study to assess problem-solving skills do not really do so because they test what I would call inauthentic problem-solving skills. What is an authentic problem? In the case that you have a real problem in life, right? Typically, there's an outcome, a desired outcome that is known. You're an emergency doctor in an emergency room, and a patient comes in on a stretcher. You can see at once the patient is in bad shape. You've got a problem to solve. The outcome is known. Healthy patient. The question is, how do you get there? And chances are that, you know, first of all, there's not enough time to do all the possible tests, but this is not going to be a textbook case. So the question is, how do you get to that known outcome? How do you find a solution to get there? You're a hedge fund manager and you have to invest money. I mean, the outcome is known, more money. The question is, how do you get there? If you stop to think about any problem you encounter in life really falls in that category. You know where you want to get. The question is, how do you get there? So you have a known outcome, but an unknown pathway to that outcome. Now, most textbook problems, and my discipline is particularly guilty of that, is very different. Students are given a problem, and in that problem, they're asked to apply a known procedure to find an unknown answer. A car is driving along the road, blah, 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 and so on, and hits a tree, and at the end of it says, what is the velocity of the car before it hits the tree? The student has to come up with a number and a unit and maybe a sign giving the velocity of that car before it hits the tree. Unknown, and that's what he or she is going to be evaluated on. So in the back of his or her mind thinks, what are the tools I have at my disposal to calculate velocities? I have this tool, I have that tool, I have that tool, and then you eliminate whichever tool you can't use because there are not enough variables given, and then you just plug in the numbers and you get the answer. Do you see the difference? Unknown solution, known outcome, known procedure, unknown answer. I think a lot of the problems fall in the second category, and I want to illustrate that with a real problem. But before I do that, I want to briefly show Bloom's taxonomy, which I don't know how many of you know. It's due to Benjamin Bloom, who was an educational psychologist in the 50s, and it sort of lists the thinking skills, the higher order thinking skills, from lower order thinking skills at the bottom to higher order thinking skills at the top. Remembering. Understanding means that you can apply what you've learned in remembering. Then apply it in a new context. Analyzing an information, extracting the important parts of it, evaluating it at the absolute top, creativity. I'm going to make an argument that we really, typically in our assessments, dwell near the very bottom of that pyramid and never get to the type of skills, analyzing, evaluating, creating, that we really want to get to. Let me make a little example. Let me use a concrete example here. Enrico Fermi, Nobel Prize winning physicist, is known to have started his classes by always asking what is now known as a Fermi problem. It's an estimation problem. The idea is, you know, estimation skills are important no matter what you do, whether you're a physicist or in business or in management, you name it. Estimation is really crucially important. So he would walk into his classroom and say, how many piano tuners are there in Chicago? I don't know, 200. You could guess, but there's not much, you know, certainty in that guess. The other thing is that you could start to estimate. Well, it's about 10 million people in Chicago. Let's say there are 2 million families, right? Dividing it by 4 something. So let's say that 1 in 10 families have a piano. So that means there are 200,000 pianos in Chicago. How many piano tuners would you need to keep 200,000 pianos in tune? So you need to make an estimation of how many, how often people tune a piano. And anyway, by thinking it through, you develop very important reasoning skills. And at the end, you come up with an answer that you can have much more confidence in than a wild guess. I'm a physicist. I don't claim to be Fermi, but by long shot. But I have often things like that happen in my own life. I was painting the dining room and many years ago, and on a Saturday morning I ran out of paint. So I went to Harvard Square, and there's that hotel there. I think it keeps changing name, the Harvard Motor Lodge or the Harvard Square Hotel. Those of you who've been at Harvard Square may know it. It has actually a parking garage underneath with 20 spots on one side and about 20 on the other. One side borders Mount Auburn Street and the other the street that runs in front of the Charles Hotel. So typically what I do is I pull in, no spots. I pull out, you have to pull into the street again, and then pull the other side, no spots, and I go to Mount Auburn Street and then back in, 20 spots. And I keep going around until somebody frees up a spot. Now, typically what happens is that you're on the left side, and then somebody on the right side, and then you pull out quickly, but you have to go through traffic, and by the time you're there, somebody else has taken the spot. That Saturday morning, I decided, you know what, I'm going to give up on one half. I'm just going to stop here, turn off the engine, and wait till somebody frees up a spot. And strange physicist that I am, I thought, let me try to estimate how long I have to wait. And I thought about it for about 20 seconds and then came up with 3 minutes and looked at my watch. Sure enough, 3 minutes later, somebody came. I felt so good, you know, that I'd be able to reason with you. Now, imagine we put this on an exam, right? We say, on a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before somebody frees up a space? I don't know about you, but I can guarantee you that if I put this on my exam, the students will go to the dean to try to get me fired. But let's think about this. What are the type of skills you need in order to answer that question? You need to make assumptions. You need to develop a model. And then you need to apply that model. Right? In terms of Bloom's taxonomy, you're pretty much close towards the top, right? You need to analyze, you need to evaluate, you even need to create a model. So you have a lot of creative thinking in there. Of those things that I've listed on the left, what is the thing that the students hate the most? Assumptions, yes, because there's uncertainty there, right? If I forget on my exams to specify something, like gravity or friction or whatever, hands go up. Am I supposed to assume here that they want you as the instructor to take the responsibility for the assumption? They don't want to take the responsibility because what if the assumption is wrong? But think of it. Making assumptions, no matter what it is, whether art history or management or physics or biochemistry, is crucially important. Anyway, given that they hate that, let's take the assumption out. We add the sentence, on average, people shop for 2 hours, right? I mean, 2 minutes is clearly too short, 2 days is too long. And I think, you know, maybe we've chipped a little bit at the top of the pyramid, but we're still pretty high, and students are still going to complain and try to get you fired. Because they'll say, what does this have to do with physics? You know, they don't see the development of a model as relevant to what they need to learn in college. So let's take the model out. We put it in there. We say, assuming people leave at regularly spaced intervals. Now we've dropped down all the way to the applying because the model is implicit in the problem. And still, students are going to scream bloody murder because they've never done a parking lot problem. So let's now turn it into a standard back of the chapter textbook problem. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area where people are known to shop on average for 2 hours. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before somebody frees up a space? You say, wait a minute, isn't that what we started with? Yes, but somewhere in the book or in the course, there's this equation, which is colloquially known as the parking lot equations. And the students have memorized that equation, and all they need to do is use a calculator. And now all of a sudden, boom, we've gone all the way to the bottom because all they need to do is remember that equation. Now, I've exaggerated maybe a little bit, but I think that a lot of the assessment that we do actually falls into this category. And we miss an opportunity to really train these higher level thinking skills that we really want our students to accomplish. To some, it will come naturally, and they will become professors. What about all the others? So, you know, and this is particularly important because computers can do this. And any problem that requires retrieval of information or application of procedures can be done by a computer. And my prediction is that just as robots have replaced assembly line jobs, so will computers replace any jobs requiring procedural problem solving. Right? We should do the jobs that machines can't do, not jobs that machines can do. So therefore, we really must focus on authentic problems rather than inauthentic problems. But there are lots of problems with inauthentic problems. With authentic problems, pardon me. One is that you don't have a straight path to a solution. Anything that involves creativity or innovation, you try one thing, it doesn't work. You have to go back and try it again. Another path doesn't work. And students hate that because there's an uncertainty in that process. And I would say our grading is incompatible with it. Students are afraid of making mistakes because what happens? You make a mistake, you lose points. Yes?
Say, not just students, people take that.
People, yeah.
We try to avoid thinking unless
Yeah.
we're forced to.
But in a sense, we avoid that because we feel we're getting punished if we do. We do not create an environment where people feel free to explore, make mistakes, and say, it's okay if you made a mistake, let's try it again and improve, which is really the path to any innovative or creative solution. 1, 2, 3. Yes?
I guess I disagree slightly when you say people don't like making mistakes. Older people don't like making mistakes. Have you ever taught 6 or 8-year-olds? Their hands are up there all the time. They're engaged. They're asking. You can slam them down. They're not afraid. So
Yeah.
it's not quite just that. These students feel like something at stake.
And
Makes them more timid.
and perhaps because the assessment beats it out of them. Yeah.
Also, what's the, so because there are many options, it's almost easy to pick up something that won't give the outcome, but multiple things can give the outcome. So when we think about the assessment as a way to give feedback, how do you make the students see that this is not that the professor, you don't know what you're asking or what you're grading, or there's an unfairness in the grading,
Yeah.
but that they understand there are multiple ways they can do it and each could be equally correct?
In fact, you mentioned something really important. I think, and this is, I think to an engineer this will come naturally, but in many other fields it doesn't, is that in a real problem, there is a multiplicity of solutions. In other words, there's not one correct solution. Chris Rogers, who is on the faculty at Tufts, gave a wonderful little presentation in my class where he basically gave every student a little bag with 6 Lego pieces. And then he told the students, build a rubber duck. So people were playing with these Lego pieces, and of course there are almost infinite number of ways of putting 6 Lego pieces together. Some of which don't look like a rubber duck at all, but some which look somewhat like a rubber duck. And at the end of 2 minutes, he said, let's now put all the rubber ducks on the table. And at that time, there were 40 students in the class I was teaching. There were 40 rubber ducks on the table. There were only 2, and they all looked more or less like a rubber duck, but there were only 2 that were identical. So there are many ways there's not one outcome, there are many outcomes. I would say in any problem, so in a sense you can quantify the amount of creativity involved by looking at the multiplicity of solutions. If there's only one solution, no creativity involved, none, because it's just a straight path to one given solution. If there are 5 different solutions, it's more creative. If there are 100 different solutions, as many as there are students in the classroom, then the diversity of solutions is high, the creativity is high.
My point was like, a lot of the times the expectation from the students is a solution or an answer to something. How do you convey to them this importance of this multiplicity without making them feel like you don't know the right answer or you're trying to hide the right answer from them?
Yeah.
And you think outward.
Yeah. So we really need to change our grading system there. Yeah. The first time I gave this talk here was at a school in Hillsborough, California, which is an affluent suburb south of San Francisco. And it was the faculty of that school. It's an elementary school and a middle school, and now they're adding a high school to it. And I asked the faculty to give the reasons, and they came up with exactly the same reasons. But there were about 4 8th graders who were sitting in the audience, and they all had their hand up. They were eager to say why they were what they saw the assessment. And I was expecting them to say, to force us to learn and so on. Nothing. It was all about reflection. It provides an opportunity for me to. Later, I learned that they have no grades at that school. None. They have no grades. Those students were looking at the assessment as an opportunity to learn, not as a filter. So I think the first thing, and you're pointing in the direction already, is, let's use the assessment as an opportunity to learn rather than as a filter, especially since we know that the filtering doesn't work in the first place. It's a myth. It's the same thing as the assessment of us. The questionnaire, rate the professor on a scale of 1 to 5. It's meaningless. I gave these lectures, thought I was a good teacher. The students did not even learn Newton's laws. I got 4.2 or 4.5. I should have gotten 0. Then I changed my approach to teaching. Nothing happened to my evaluation. They learned a lot more. So it's an irrelevant metric. Yeah. And I'll tell you why we stick to that irrelevant metric in just a second.
Well, it's the same thing talking about assumptions when I said if assessment is for students to understand what they don't understand and what they do understand, we need always feedback for the professor.
Feedback to the students, I meant.
Oh, no,
That's what I meant.
for themselves.
Yeah, that's what I meant when I said feedback.
So, to me, assessment, for whom is the assessment? Is it to the professor or is it to the student? And to me, the crux of the problem is the student is the one that needs to look at how they learn, why they learn, and so forth. So self-assessment, for me, it's very important.
Absolutely. I couldn't agree more. Yeah.
And they're pretty savvy when they do self-assessment in the class.
So I want to flash a picture here. I mean, you see right away what's happening here, right? And if this picture evokes pleasant memories, I would like to talk to you at lunch, okay? When you look at this picture, what is sort of the emotion that comes up? Tension, stress. What else? Anxiety. Aren't those wonderful feelings to have when you're learning? Okay, what else? There's something else that jumps out from this picture. Individually, on their own, I would actually say isolation. Ask yourselves, I mean, I'm sure you can remember those moments. Ask yourself about your work or the work of anybody in any of our students' professional careers. Since you left college or graduate school, have you ever encountered a situation where you're cut off from information, cut off from each other, isolated like that? When I write a paper on nanophotonics, which I do because that's my field, there's nobody standing next to me saying, in my office saying, you're not allowed to look up that paper by your colleague at Yale, you should have known it by heart. I can look up whatever I want. I can consult whoever I want. Why do we assess our students in a situation that they're never going to encounter in their professional lives? Why? What are we trying? Something really interesting happened. I'm sure I was not on campus. I was in Hong Kong, but I got the news almost right away on my phone of this bomb scare during exam period at Harvard about a month and a half ago. A few hours later, I got a note from the dean saying that the exams would be suspended, and that he realized that it was really annoying for the students because they had studied for the exams. And, if you wait too long, then they don't... Seriously. Isn't that admitting that there's something really, really, really wrong? Because shouldn't they learn for life rather than just for the exam? Anyway, so it culminates, of course, in the final exam, which is a high-stakes affair. But as we know, what happens is students cram. And in fact, many faculty encourage students to study for the exam, like the anecdote I just told you. And as a consequence, things only go into short-term memory, and students forget what they've learned immediately afterwards. No transfer, no retention. So I'm going to skip through this, but I want to point out two other things. One is the assessment produces a conflict too, and I noticed that when I transitioned from a lecture-based course to a project-based course, because I find myself during the year not in the position of an assessor, but of a coach, right? When they work on the projects, it's fantastic what happens when you give students ownership of their learning. They turn into little kids again. You can't stop them. Okay, and all these students work in teams on these projects. I want to give them all an A. And when we get to the fair, all of a sudden, there's this Jekyll and Hyde transition. And instead of being their coach, now all of a sudden I have to judge them. If you stop to think about it, there's no other human activity where that happens. I mean, you couldn't have a figure skate coach go to the Olympics with whoever he or she has been coaching and then become a judge. Or have an electrician install the lights, and then he's the one who, you know, certifies that he's done a good job. I mean, the evaluator is always somebody different from the person who does the training, but that's not what we do when we teach. So how do we resolve that? And this is where I'm going to stop because lunch is being served, and I don't want to go too long, but this is the last problem I'm going to say, and then the solutions, I have to refer you to my talk online, I'm sorry. But how do we resolve this conflict that we have? We resolve it by hiding behind objectivity. We try to apply a measure where we can say, that's it. This is objective. You know, there's no emotions or feelings involved. That's the only way we can resolve that conflict. But the only way we can do that is by sticking to the very bottom of that pyramid. The only thing you can really assess objectively are things that are not very authentic. In what year did the Dutch defeat the British in the River Thames? 1660, I forgot, I'm sorry. I learned that because I'm Dutch, so I think 3, but I'm not sure. Right? Right or wrong, there's no interpretation there. Creativity, evaluating, all these higher order thinking skills you cannot judge objectively. So what do we do in order to resolve that conflict? We stick to things that are objective. Okay, I wish we had more time, but I see the students are there, and it'd be horrible to disappoint them and not let them present. I mean, the rest of this presentation, where I have 4 very modest proposals for improving assessment. I mean, you can fly through it online. I'll send out the URL. And I'm local, so I'm happy to continue this dialogue anytime. I hope I've stimulated some thinking.